Chapter 8, Astronomy, Section 2, Digging Deeper, the Celestial Sphere. In the Investigate, you explored different approaches and models for locating places on Earth. You then investigated a coordinate system as a mathematical model for finding objects in space. Locating objects in space has been a challenge for people for a very long time. For thousands of years, people from all parts of the planet recognized patterns in the groupings of stars in the night sky. The Greeks, Egyptians, Babylonians, and others gave names to the groups of stars. They told stories about them that allowed for their positions to be learned without needing instruments. Some scientists think that caves in France may contain drawings of the night sky from 17,300 years ago. Figure 1 shows an ancient star chart. Figure 1 is an ancient star chart showing animals and objects that represent the constellations. Observations of patterns in the locations of stars have led to the organization of 88 groupings of stars in the sky. Astronomers call a grouping of stars a constellation. Each constellation has a Latin name. The name is given a 3-letter abbreviation. For example, Cassiopeia is abbreviated as CAS. Draco is abbreviated as DRA. Constellations are important reference points for locating planets and other astronomical objects in the night sky. Many ancient astronomers thought that the stars were attached to a giant hollow sphere that surrounded Earth. Astronomers now know that such a sphere does not exist. Stars are located throughout space at different distances from Earth. However, the idea of a giant sphere called the celestial sphere is useful. It provides a model on which to place and locate stars, planets, and other objects in space. The word celestial means pertaining to the sky. The difference between astronomical objects and celestial objects is that celestial objects do not include Earth. In Figure 2, the view of the celestial sphere looking toward the north celestial pole. Okay, so here's Figure 2, which is a view of the celestial sphere looking toward the north celestial pole. To describe the location of an object in the sky, astronomers use a special reference system. It is a mathematical model known as the celestial coordinate system. This system uses numerical coordinates similar to the ones used for locating objects on Earth's surface. The numbers are measurements from known reference points or lines. These lines are similar to lines of longitude and latitude. The main reference line in the celestial sphere is the celestial equator. It is an imaginary circle created by extending Earth's equator into space. In Figure 3, locations on Earth's surface can be precisely located using longitude and latitude. The celestial coordinate system uses declination to measure how far north or south an object is from the celestial equator. Declination is similar to latitude. It is measured in degrees. The celestial equator has a declination of 0 degrees. Objects north of the celestial equator have a positive value. Those south of the celestial equator have a negative value. On Earth, longitude is measured east or west of the prime meridian. The prime meridian is located at 0 degrees. It runs through Greenwich, England. Like all other lines of longitude, it runs north to south. It converges with all other lines of longitude at the poles. If you look down onto a globe at the North Pole, you can see 360 degrees through which Earth rotates every 24 hours. It rotates through an angle of 15 degrees every hour. According to these different measurements for longitude, the city of Miami, Florida, lies 80 degrees or 5 hours and 20 minutes west of the prime meridian. Los Angeles, California, lies 118 degrees or 7 hours and 52 minutes west of the prime meridian. In the celestial coordinate system, the lines that correspond to longitude on Earth are called right ascension, or RA. Right ascension is measured in hours. Right ascension is measured in hours, minutes, and seconds. Much like lines of longitude can be measured, right ascension is slightly more complicated to understand than longitude. Due to Earth's counterclockwise rotation, the pattern in the movement of objects appears to be across the sky at night. Earth's eastward rotation causes stars to appear to move. Earth's eastward rotation causes stars to appear to move west. Thinking about the rising moon might help you understand how this works. The moon appears to rise above the horizon from a given point on Earth's surface. As Earth rotates, that point moves away from the moon, which appears to rise upward and to the right. Similarly, Earth's rotation causes the pattern in the positions of the stars in the sky to appear to change gradually throughout the night. Figure 4 shows the trail of the rising moon over Seattle. Okay, so as you can see, they took a time-lapse photo, and the moon appears to rise over Seattle. In order to properly measure right ascension, a fixed point is needed. The sky lacks a fixed point. Even the stars are moving as they slowly orbit the center of the galaxy. As a result, astronomers have chosen the point on the celestial equator where the sun crosses into the northern hemisphere in spring. This is a point in time known as the vernal equinox. Notice that this point does not coincide with the point where the prime meridian intersects the equator. The stars seem to have a pattern of movement in which they travel across the sky at night, and the sun seems to travel across the sky during the day. While it may appear that these objects are moving, they are not. The reason for this motion is because Earth rotates 360 degrees about its axis every 24 hours. The points about which the sky seems to rotate are called celestial poles. One is located above the North Pole and the other is located above the South Pole. Over time, stars located near the celestial poles make small circles in the sky. Currently, the star called Polaris lies very close to the northern celestial pole. It therefore appears to be almost stationary in the night sky. As a result, this star has become known as the North Star or Pole Star. It has been of great use in navigation. The nearest star to the Sun is Proxima Centauri, located at right ascension, 14 hours, 38 minutes, and declination, negative 60 degrees, 46 feet. All right. Figure 5 shows that Polaris is the pole star seen at the center of the concentric rings in this photograph. The rings are the apparent paths of stars produced by Earth's rotation about its axis. Not all of the stars in the sky can be seen from a single location. A person viewing stars in the northern hemisphere cannot see all the stars visible in the southern hemisphere. Some are located below the horizon. The stars that can be observed from any given place also vary throughout the year. As Earth moves around its orbit, the north and south poles point toward different parts of the universe. As a result, different constellations and other celestial objects come into view at different times of the year.